Hello, this is Mr. Wyrick. I'm here to talk to you today about lesson 12.2, surface area of prisms and cylinders. We'll be talking about total surface area and lateral surface area today. Be sure you're kind of following along in the book. There's a lot of stuff to get taken down in the notes. The first thing that they want to talk about is the lateral faces. This can be tricky depending on how the cylinder or how the prism is shaped, and they kind of start with prisms for you, but the lateral faces are the ones that are not bases. This can be tricky if you have something like a cube, but generally if you have an octagonal prism, then it's got octagons on the top and the bottom. Those are your bases, and then all those rectangles around the outside, those would be the lateral faces. So you have to kind of pay attention to how this one's going to work. Be careful if it's a rectangle, because there can be different things there, but they probably won't try to trip you up necessarily on this. On some standardized tests, they may mess with you a little bit more. The lateral edges are the intersection of those lateral faces, so the pointy areas on the outside. An altitude goes from the bottom to the top or front to back, depending on how your prism is facing. And it's perpendicular to those bases, and it joins the bases. Now that's granted that you have one that is not oblique. Out here I've kind of pictured one that's oblique. There's a better oblique one because they can kind of do some 3D type of stuff, and I was just hand drawing this, but oblique means the whole thing is kind of leaning. Okay, so it's got a parallelogram kind of look to it. So it's tilted over like this, and all these lateral faces would be parallelograms instead of rectangles. The height is the length of that altitude, or the length from one base to another if you have an oblique. The lateral area, or the lateral surface area, is where you just do the lateral faces. I like to think of this as the label. If you have something like a Pringles can or a soda can, something like that, where there's just a label around the outside and those top and bottom bases don't have that label, that's a good way to kind of visualize this when you think about lateral surface area. It's the perimeter times the height. You have to be careful if they give you triangular ones like this, where the triangles are at the front and the back. That's still, those triangles at the front and the back are still the bases in this case. So you'd find the perimeter of that triangle and multiply it by the length from one triangle to another. That's still considered the height. Conversely, if you get mixed up by this formula of trying to do the perimeter multiplied by the height and forget, just remember that it's that label area. So if I was dealing with kind of a cube or a rectangular prism here, I can just say, okay, this is lateral, the back one back there is lateral, and this one's lateral. I can just find the area of each one of those squares or each one of those rectangles, and then add those all together. That would be my lateral surface area. It's just this formula kind of gets you there a little bit quicker. Then we're dealing with cylinders. When you're dealing with a cylinder, you have an axis. The axis connects those two bases, those circles, from center to center. It can either be right or oblique. Again, if it's oblique, the whole thing's kind of tilted to the side. If it's right, then the axis is the same as the height. If not, you'll have to find the height again separate, just like we did up here. The lateral surface area, the 2 pi r is the circumference of that circle. Because if we unfolded this, if we made a net, which I know you've seen nets on some of your previous work, we'd have a net something like this with the bases at the top and bottom, and then this rectangle here. The circumference of this circle is this length of that rectangle. So then this here would be the height. So we get the circumference of that circle, we multiply it by the height, and that label there, as we unwrap it, that's our lateral surface area. If we get the complete surface area, which they will ask you for, I like to think of this in terms of what I'm finding. I'm finding the circles and I'm finding the rectangle. So it's either the lateral surface area plus 2 of the bases, or if you want like a formula, 2 pi r squared plus 2 pi r times h. Again, circumference times the height, and then this pi r squared is the area of that circle. We multiply it by 2 because we have 2 circles. That should be it, although I think there's a vocabulary word hiding later. Yes, on page 852, make sure you look back at page 852 to where it's got something there about composite solid. It's saying it's just like when we were finding the areas of composite figures, you figure out what it's made of. And then once you have that, again, you can find perimeter of that and multiply it by that height to get your lateral surface area, or just find the area of each side to get that total surface area if that's what you're looking for. On this, I would like you to go ahead and do numbers 9 through 38. 9 through 38 will be the problems that we address on this one. If you have any questions on it, if something in this explanation didn't make sense, you couldn't stop, you couldn't zoom in, you can't read my handwriting, whatever it is, if you've got some of those issues, come by, talk to me in tutorials, or just raise your hand during class and we'll get it worked out. We'll see you then.